let's talk about diagonals for rectangles and parallelograms. Now, a diagonal on a rectangle, diagonal just being a line segment that connects the corners, forms some interesting isosceles triangles. Always isosceles triangles. You'll notice that the diagonals here, these lines connecting your corners, cut each other in half into two isosceles triangles that are obtuse. Those are the up and down ones. And then the side to side isosceles triangles are acute. Now we're going to use this idea of isosceles triangles to solve a problem like this. It says find the measure of the following angles in the rectangle. Now if I know that these are all isosceles triangles, I know that this base angle is congruent to this base angle, which is 37. Now one thing I will point out is if I know that this angle is vertical to this angle number 5, I can solve for that, remembering that every triangle adds up to 180. So I'm going to look at this triangle and think about how it adds up to 180. I'm going to take those 37s away from it. That's going to solve for that angle. That's going to give me 106. So I know that this is also 106. So at least I know my angle 5. Solve for angle 1, the thing I'm going to look at is how I see a straight line right here. Now, if I have a straight line, I know the straight lines add up to 180. We have a linear pair. So I'm going to take that 180. I'm going to minus 106. And that's going to give me angle 1. That's going to give me 74. So I know that gives me 74. Okay, if this is a 74-degree angle, then another thing I know is I have another isosceles triangle right here. So I know whatever this is, angle 2 is over here as well. So I can take 180. I'm going to minus that 74. And that's going to give me the 106. And that 106 needs to be split evenly between these two other angles. So I'll divide by 2. That's going to give me 53. So I know this angle is equal to 53, and this angle is equal to 53. So that's going to be angle 2. I guess I forgot to fill in the answer here that I know this is 74. Now let's look for angle 3. Oh, well, angle 3 is easy enough. I already know that this angle here is part of an isosceles triangle, and I already know the vertex or the big angle right here. I know these two isosceles triangles are actually congruent, so 37 degrees, because these two angles are the same. Now, if we use that same logic from 2 to 4, if I know 1 is 53 degrees, if I know angle 2 is 53 degrees, I know angle 4 is also 53 degrees. So I won't have to do any solving there. Let's look at this triangle. Now, we don't see the diagonals intersecting. How unfortunate. But it's a rectangle, right? Now, rectangles have right angles. Hey, that's a right angle. That's a right angle. So I know 1 and 4 automatically are 90 degrees. Now, if this is 90 degrees and this is 53 degrees, if I take that away from 180, I can use the fact that this is a triangle to solve for angle 2. Which gives me 37. Let's look at angle 2. Oh, sorry, I just completed that. 37. Okay, now I know this is 37. Now, everything else is given to me. Now, one thing I do want to point out to you guys is that on a rectangle, lines are parallel. And this line right here, this diagonal, could also be considered a transversal, making these alternate interior angles, meaning that angle 5 is congruent to angle 2, so angle 5 is also 37 degrees. Now, if we applied that logic to my vertical sides, if I said, hey, this line is parallel to this line, and this still makes a transversal, then that would mean angle 3 was congruent to this 53-degree angle. So angle 3 is 53 degrees. Okay, let's look at parallelograms. Notice here on the parallelograms, while the parallel sides while the diagonals do bisect each other, they are not congruent. So we don't have that nice idea where we have isosceles triangles. We do have some congruent pieces, so we have congruent triangles, but not isosceles triangles. Let's use that on this example. Now, first thing, I'm going to just fill in everything that I know. One thing I know, this is 119 degrees because it's a vertical angle. I also see that this forms a straight line here, linear pair. So I'm going to take that 119 and I'm going to take that away from 180. And that's going to give me 61 degrees. So I know this is 61 degrees. Okay, now I also know that vertical angles makes this 61 degrees. Okay, let's see how much of that is useful. Let's solve for x first. Hey, look, a triangle. Well, that means I just need to take away from 180 the two other angles. In this case, that is 28 and 119. Which is 33. So x is 33. Splendid. Now let's look at another angle pair we have. Oh, I see this triangle. I see this angle, I see this angle. Let's take them away from 180. That yellow is kind of grating on the eyes. I'll switch to gold. So I'll take that 180. I'll minus 61, and I'll minus 74. Guess that 61 did come in handy. I'm glad we did that. That's going to give me 45 degrees. Okay, the last thing I want to point out to you is this is a parallelogram, which means you have parallel sides. So if I look at this side and this side, and I extend this to be a transversal, then that means that Z is alternate interior with Y, so Z is also 45 degrees. Always use your parallel rules as much as you can to save yourself some time. Look at this one. This parallelogram is just split by one diagonal. Now again, I see a triangle, so I think I'm actually just going to solve for solve for Z first. I'm going to take that 180, and I'm going to subtract 56, and I'm going to subtract 61. That's going to give me 63. Looks like I crossed out where I was supposed to put my Z, so I'll just write it down here. So I know this is 63 degrees. I also know, by virtue of this being a parallelogram and this being a transversal through two parallel lines, that 61 and Y are congruent. So this is 61. Well, if this is 61 degrees and by looking at these parallel lines and this transversal, I know this is 63 degrees. Well, then what do you think x is? 61 plus 63, we've already proved it needs 56 to make 180. So we'll just fill in the 56 just like over here. Yay. That's all we need to talk about for today.